Good day, everyone. So for today, we are going to discuss the greatest common factor of two or more monomials. To define, it is the product of their common factors when each monomial is expressed as a product of prime factors. Okay, so let's have an example now. Let's have first getting the greatest common factor of two numbers. For example, 12 and 60. Okay, now for us to get the GCF of 12 and 60, we should get first the prime factors of this. Now you may use strategies in getting prime factors such as the prime factorization or the 3 factor. Okay, so let's start first with 12. Now, it is also important that you know the divisibility rules. Okay, so let's have 12. Now, since 12 is an even number, therefore, we can say that 12 is divisible by 2. Therefore, one of its factors is 2. 2 is already a prime number, so let's encircle it. Now, 12 divided by 2, we have 6. Therefore, the other factor is 6. Now, since 6 is not yet a prime number, we need to get its factors, which are 2 and 3. 2 and 3 are already prime factors. Okay, so we're done with 12. We can now list down the factors or the prime factors of 12, which are 2 times 2 times 3. Now, if you want to check if you get the correct factors of the given number, you will just multiply. So, for example, we have 2 times 3, which is really equal to 12. Okay, now let's go to 60. 60 is also an even number. Therefore, we can say that one of its factors is 2. And 60 divided by 2, we have 30. This is also divisible by 2. And 30 divided by 2 is 15. Now, since 15 ends with 5, therefore, we can say that this is divisible by 5, which is already a prime number. Now, 15 divided by 5 is 3, which is also another prime number or factor. So, we can list down now the prime factors of 60. We have 2 times 2 times 3 times 5. Okay, now just a suggestion, list down the numbers or align the common factors of the given number so that it will be easier for us to determine which are really common. So for example, I have here 2 is aligned to 2 and then 3 is aligned to 3. Okay, so let's get now the GCF. Again, GCF meaning greatest common factor. So we need to get the common factors of these two numbers. So we have 2 times 2 times 3. Now, since 5 is not common to both 12 and 60, we will not get 5. Therefore, the GCF now is equal to 2 times 2 times 3, which in simplified form is equal to 12. Okay, so let's write 12. Now, how are we going to check if 12 is really the greatest common factor? We will just divide 12 by 12 and 60 by 12. Now, since both 12 and 60 are divisible by 12, then we can say that it is a common factor. Okay? Now, let's go to 20a squared b and 12a squared b squared. Now, this is an example, or these are the examples of monomials, okay? Because there are variables, numerical coefficients, and exponents, okay? And we only have one term. Now, for you to get the greatest common factor of this, it's important that you know or you identify the prime factors of the numerical coefficients, okay? So, let's start with 20. 20 is an even number, therefore this is divisible by 2. So, we will have 10. 2 is already a prime number. 10 is an even number, therefore we have 2, another 2. And of course, the other factor will be 5. So for 20, a squared b, the prime factors are 2 times 2, or I can also write 2 squared, whichever you want. But in this example, let's use 2 times 2 times 5. Then copy the variables with its exponents. So we have a squared b. Okay? And let's get the prime factors of 12. Now, since we have already get the prime factors of 12, we will just copy it in the previous example. 12, the prime factors of 12 are 2 times 2 times 3. So, if we have 12a squared b squared, this is equal to 2 times 2 times 3 times a squared times b squared. Now, let's get the common factors. Okay, so we will have GCF. One common is 2. Another 2. Now, 5 and 3 are not common. And then we have a squared. Now, in this case, b and b squared is not common. But if you're going to factor b squared, that is equal to b times b. Okay? Therefore, between b and b squared, the common among 2 is only b. Okay? So, we will just get b, not b squared. This is not included because b squared is not common between the two monomials. So, let's write it. We have 2 times 2 times a squared times b. Let's simplify. This is equal to 4a squared b. Okay? So, the greatest common factor of 20a squared b and 12a squared b squared is 4a squared b. Okay? Now, let's go to our last example. In here, we have we have 3 monomials. Okay? So, let's get first the factor of 15x squared y squared. Now, we will just get the prime factors of the numerical coefficient, which is 15. 15 is equal to 3 times 5. And both 3 and 5 are prime numbers or factors. So, if we have 15 x squared y, this is equal to 3 times 5 times x squared times y. Next is 9. Prime factors of 9 are 3 times 3. Okay, so if we have 9x cubed y squared, this is equal to 3 times 3 times x cubed times y squared. But in this case, I'll just write 3 squared since we have 3 times 3. Anyway, 3 squared is equal to 3 times 3. So, 3 squared times x cubed times y squared. And the last one is 12. We know that the factors of 12 are 2, another 2, and 3. Okay? So, we have 12x raised to 4 y cubed, which is equal to 2 square times 3. Then we have x raised to 4 times y cubed. Now, just a suggestion, if the factor or if the given number or factor has an exponent, to get the greatest common factor, you'll just need the number with the lowest exponent. So, for example, 3, 3, 3. The highest exponent is 2, but since 3 squared is not common to all of them, then we will just get the one with the lowest exponent, which is 3 raised to 1, or simply 3. Okay? And then, in here, they're all x, but we will just get the one with the lowest exponent, which is x squared. Okay? So, x squared only. We will have 3x squared. And the same thing with y. The one with the lowest exponent is y. Okay? Therefore, the GCF of these three monomials is 3x squared y. Okay? That's all. I hope you learned something. Thank you.